Welcome everybody. I'm John Laker. I'm one of the directors of Marlow Energy Group. Tonight we have a talk from Leigh Fairbrother, who works for a company called Cubot. Just to introduce Leigh, he's head of the sales of Cubot, and he has a background in architecture, has been working on energy efficiency related projects with social housing providers for over a decade. He is passionate about the decarbonisation agenda and keen to help householders reduce demand for heat and improve the quality of their homes. Leigh is on his own retrofit journey with a complex project of his 210-year-old home, and happy to share his knowledge and experience. So, getting back to the agenda, if I can introduce now Leigh, I'm going to move to speaker screen so we can do that. So it's over to you. You can share the screen whenever you want it, Leigh.
Fantastic. Thank you very much for the introduction. I'll just share my screen. You should all be able to see what is actually a Mark 7, 7th generation of underfloor insulation robot. We affectionately refer to the robots as Betty, although they all have individual names. But Betty is the robot that we use at exhibitions the most. She's not done a day's work in her life. She's very clean and presentable. Thank you for finding the time to join us this evening. Thank you for the introduction, John. As you mentioned, I'm head of sales at Cubot. I've been here for about 18 months. I joined in the first lockdown, but Cubot is a company that I've been aware of for many years. They were formed in 2012 and did their first installation of underfloor insulation in 2014. And since then, demand has been growing exponentially. We're currently installing the Cubot measure in over 100 properties a month up and down the country. Our split is between three main channels, which is homeowners like yourselves, which makes up about a quarter of our channel, and 75% is between partners and social housing providers. And many of those partners delivering directly to the social housing market. But yeah, I'm going to take you through a presentation, some slides, let you get an understanding of how this particular part of technology we've developed works, the benefits it brings, and the requirements for it. I'm more than happy to answer any questions anybody has. Because it's a small group, we put your hand up midway through if there's something pressing, or we can take questions at the end. You've got my email and contact details on the bottom of that slide. I think they're repeated again at the end if anybody wants to get in touch with me directly after this evening. So, Cubot's vision is to make it easier for contractors, organisations and individuals to inspect, maintain and upgrade buildings with a focus on being able to provide quality retrofits and really bring the construction industry into the 21st century. As some of you may be aware, the construction industry works in very unsustainable ways. Quite often building developers will order at least 10% extra materials than they need for a job, because from their perspective it's far lower risk to have extra waste rather than the risk of running out of materials and being idle. But our solutions are designed to combine technologies like robotics, three-dimensional surveying, scanning, digital tools and artificial intelligence to make it easier to identify the needs of individual properties, automate the processes with which are required to design and retrofit them, reach parts of the properties that humans is either high risk or inaccessible, and then track that work and seamlessly share it. introducing a level of quality assurance that's not necessarily been associated with the construction industry. In bringing Betty, or Underfloor Insulation, to market, we've actually developed 3 standalone platforms. So we have our digital twin platform, which is 3-dimensional visual, LiDAR and thermal scanning combined to create digital twins of properties, which can be used for design purposes, measuring performance and calculating the benefit of retrofit. We have a robotics platform. The Underfloor robot is the most recognized of which, but we have developed a number of other robots, which you'll see some of those commercialized over the coming years, addressing other parts of the retrofit journey and other parts of the built environment. And finally, that's all stitched together with our retrofit management platform, or information management system, which gives our clients access to the information that we capture from survey and install, and robots capture whilst they're working, so that we have really robust quality assurance process, which has allowed us to get a number of awards and accreditations and be eligible for funding streams as well. All of those can be used individually or together as a multidisciplinary approach, depending on what a particular organisation or individual is looking at for their home. So why underfloor insulation? Well, when Cubot was founded in 2012, it was done so by an architect, an engineer, and a senior lecturer in robotics at UCL. Tom Lipinski, the architect, was actually under a floor installing insulation in the traditional method, and thought, well, there has to be a better way to do this, because the job that was being done obviously has limited performance capacity. Market research shows us that there's at least 8 million, we think it's more like 8 to 12 million properties in the UK that were built with a suspended timber floor. And that's part of that ventilation strategy of that building type of that time. As you can see from this diagram, properties have air bricks below the floor level, which allow air to be brought in through the floor, which would typically have fed open fires on fireplaces. Obviously, we've moved on and we've introduced central heating in the last 50 years, but the properties that we live in are often older, and they still have these vents, they still have suspended timber floors, and that means that we have a huge amount of uncontrolled air infiltration, lots of drafts coming into properties. Because of that, and because you've got a void with cold, moist air underneath your property, you're losing about 20% of your heat through the floor. And about a third of all the drafts or the air infiltration in a property, it comes through those floors and those vents. Because it's uncontrolled, it doesn't help to heat a property. It makes for very uneven temperatures. The moisture that's coming, the air that's coming in from the outside is often moist, much more moist than it would necessarily want it to be. And therefore that cold, damp air coming into a centrally heated home runs the risk of condensing on the warm surfaces, creating issues of damp and mold as well. Traditional methods are incredibly disruptive. If you don't have the space underneath the floor for a human to access it, and that we find is the majority of cases, then you need to lift the floorboards in order to insulate the floor. That means taking out all furniture and fixings. And if you're living in that home, that means decamping somewhere else. What might be done then is either the application of a mineral wool or an extruded foam, which is fitted between the floor joists. But that obviously doesn't resolve the air tightness, so you still have cold, damp air coming through. It's incredibly messy. As you can see here, an example of fitting extruded polyurethane foam between floor joists. You're basically stripping the building back to its beginnings. Because of that, because of the cost, because of the level of disruption and the low performance, we estimate that only about 1% of suspended timber floors in the UK are currently insulated. It's time consuming. Most people wouldn't want that. And because the floor itself is wooden, over time it will move, and that will generate gaps with natural and traditional methods that mean that you can either trap moisture or still continue to have uncontrolled air infiltration. So Cubot developed a robot specifically designed to work in the really difficult environments underfloor, which can spray a high performance polyurethane foam which creates a seal with the floor and increases the the thermal performance whilst also reducing drafts and the risk of damp and mold. Current average install cost is about £3,200. It varies obviously depending on the size of the property, and therefore we see it's probably the next most cost effective SAP improvement measure after loft insulation. For those of you who understand energy performance rate certificates or EPCs, they are based on a number of SAP points. The more you have, the more efficient your home is, all the way up to 100%. And we're tasked to get to net zero to get all domestic properties in the UK to at least 86 SAP points, with the assumption that the decarbonisation of the electricity network and the removal of methane gas will account for the remaining 14%. So because of the work we've done, because of the robust processes and quality assurance systems we have in place, we've ensured that Cubot is actually recognised as an eco measure, which is energy company obligation measure. It's also recognised as a primary measure for all the Green Home Grant schemes. So that did include, although it's come to a close now, the voucher scheme for homeowners. It's a high performance foam, forms a hydrophobic barrier which protects the floor, which means it's essential that during the survey stage, we ensure that the moisture content levels of floor joists are below 20% and therefore it's safe to install. For those of you that are aware of us, you may have visited our website. We've developed something called an eligibility checker. It's a series of questions which help customers to understand whether their property might be suitable for our measure, and if so, take them on to the process of potentially understanding what the indicative price might be for their property, and go all the way through to booking a survey if that's something they want. They can also, obviously, on that process, schedule a call with one of our team as well to talk about the measure and their particular circumstances. It's very quick, simple to use, less than probably 30 seconds to complete. Asks you about what type of flooring you have, what type of floor coverings, if you know anything about the floor void underneath. One of the key factors we look for is the depth of the floor void. With just the Generation 7 robot that I showed you on the first slide, can now operate in void spaces as low as 200 mil between the bottom of the floor joists and the ground. Has a retractable turret, so it can be moved around effectively in very confined spaces. And we're now looking at how we can potentially make our technology even smaller, because the current bar, lowest bar, building regulations require that 150 mil of ventilation space remains. So we're looking at whether we can get that low and deliver an effective job. So what would happen if if you think you've got a suspended timber floor and you're interested in understanding if it's suitable for UFI? You go through the process online and book a survey. Our project management team would be in touch. They'd schedule a date that was suitable for you. Typically, a survey takes about 60 to 90 minutes, depending on the size and complexity of your home, and will involve creating at least one, possibly more, access points in the floor. Unlike this diagram, those access points are typically about 100 by 200 mil, so one floorboard wide between two joist centres. That allows us to make an assessment on the depth of the void, take moisture content readings from the floor joists and the flooring, look for any physical obstructions. Quite often, if there's been building work in the property since its original construction, you might find a lot of rubble down there. If a wall's been knocked down, quite often builders wouldn't take that rubble away. They just bury it, sweep it under the floor, quite literally. So we'd look for physical obstructions like that. In many cases, when we are going under floors, we're the first person to do that in a great number of years, so we might unearth other historic problems such as wet rot or dry rot, maybe rising damp on internal walls, possibly woodworm, or in the absolute worst case scenario, infestations of other types. Obviously, we want to make sure that those risks don't exist, and we'd report back on those. But if we check that and we did a ventilation study to ensure that the property was suitable, then we could potentially proceed to install, be able to provide you with a detailed quote of the exact expected install costs, and then schedule that install. A Cubot install team consists of 2 operatives, one van with the install equipment, and a robot. And the robot would be selected based on the characteristics of your property, whether it needed to be a Mark 7 or a different generation. And that's connected to the van via a tether. And we set up a control station outside of the property. That was born, obviously, of COVID restrictions last year. Access within the property through the suspended timber floor for a robot is about 300 by 400 mil. And as you can see from this diagram, you can remain in the property while it's being insulated. You're just not able to be in the room directly above that that's being sprayed. We attach some high-powered extraction to the external floor vents so that we can remove fumes and particulates whilst we're doing that install. But we would agree an install plan with an individual homeowner so that you had access to the parts of your property you needed when you needed to, and in and out of the property as necessary. Now, typically, install only takes 1 to 2 days. If you have a very large property, it might take longer, or if there's a particularly complex array of sleeper walls underneath. But on average, 1 to 2 days for the majority of installs. The robot itself has 4-wheel drive. Each individual wheel is a motor. Makes it incredibly powerful, incredibly maneuverable. That allows it to negotiate the rough conditions that it will find under a floor. And if we were to connect 2 of the robots to one of the large vans that we use, they would be able to tow it. They have sufficient weight and traction to do so. That allows them to pull around the tether, which supplies them with the foam. When the robots put into the floor void, the operator will first have a drive round. The robots are equipped with LiDAR and visual cameras in multiple locations, so we can collect data about the depth of the void, create a point cloud, so that we can later verify the depth of its foam. It also allows the operator to visually inspect areas that we perhaps couldn't reach during the survey, so we can identify any of the risks, and so that we can include things like services to be marked onto floor plans for post-install. Once that's been done, we'll move to spraying the foam. Now, the foam is applied in layers, with a very thin layer, first of all, a flash layer, which effectively acts as a seal to stop any amount of the foam expanding up through the floorboards. And then we build it up in layers of typically about 50 mil at a time. And we're aiming for a target depth of about 125 mil. And that's because most floor joists are 100 mil deep, and we want to ensure that they're encased on the bottom so that that removes the risk of thermal bridging. If we install to a depth of 125 mil, then we'll typically return a U value of about 0.18 to 0.22, which is well ahead of the requirements of building regulations for retrofitting insulation to a floor. Once that install is complete, the robot, where LiDAR is available, will create another scan, which will allow us to verify the depth of the install and therefore calculate the U value. All of that's done controlled from outside. You can see the operator outside working will have a view of the robot's cameras, and you can obviously stand with them and you can see them operating in the floor environment. It's really quite disorientating watching them driving around in the underfloor environment, because it's quite a constricted space, and it's quite skilled to understand exactly where your robot is, where it's facing, where the tether is, and so that you can have an effective install. At the end of the install process, we'll do a final check with the customer, get sign off of the work, and then we'll be able to verify it back at base. And we do the same. We have a network of accredited install partners up and down the UK, and we would verify their work as well. So what are the benefits? Well, this is a diagram of a solid wall property with an uninsulated suspended timber floor. You've got cold, moist air being drawn in from the outside. It's slightly warmer, but very humid underneath the floor. And then negative air pressure that occurs from opening doors and windows, general life inside, will draw that cold air up through the property. I can speak for that firsthand because I have a suspended timber floor myself. So yeah, so you tend to then have a very cold ground floor and warmer upper floors. Once we've applied the foam, you've created this hydrophobic barrier. You've removed the cold, moist air coming into the property and reduced the heat loss drastically. The air vents are kept clear, so the underfloor space is still ventilated, and we maintain that there's to be a minimum of 150 mil of ventilation space under there. You can see on this particular image, this diagram, because it's a solid wall property where the floor joists are embedded in the external wall, there is a tapering at the end, which allows for wicking away of moisture that might be transferred from the external wall. So what does that look like in real terms? Well, once you're inside, you've now got a much more even temperature distribution through the house. It's quicker and easier to heat the property, and it will maintain a more stable temperature. You reduce air infiltration by about 1/3. So all that uncontrolled drafts that came from the floor are now gone. Your feet will be warmer and you'll be more comfortable. Many people say that one of the primary reasons they do this is because of that comfort level. And that will obviously have an impact on reducing your energy bills. We've had a study done based on a case study of 100 properties, independently verified by the Energy Savings Trust, which shows average energy savings across all buildings and types is about £150 a year. If you have an electrically heated or oil heated property, then it will be higher than that, and a gas centrally heated property is probably be slightly lower than that. But it will have a significant impact, and it will therefore reduce your requirement for heat and therefore reduce the amount of CO2 that you are generating through heating your home. The average install, the embedded carbon, which is the material that we use, but also transport to site, the assembly of the robots, delivery, and all components of it, it's about just under 800 kilos of CO2 equivalent. Generally, for a similar sized property to that, you'll be saving about 650 kilograms of CO2 equivalent annually. So the measure is carbon neutral within 2 years, has an expected lifespan of at least 42 years, and therefore will be carbon negative to the tune of about 25 tons of CO2 equivalent. Now, the foam itself is nothing special. It's a PU foam provided by a company called BASF. It's been used in homes in the UK for 20 or 30 years. It is only really degraded by UV light. So we give it we're told to give it a 42-year life because that's about as long as it's been around. But in this underfloor environment, we don't actually expect it to degrade. So you could well get a much longer life out of it. It's probably likely to outlast the floor itself. Because you haven't got cold, moist air coming into the property, you reduce the total amount of moisture in the air, so you're reducing risk of damp and mold. So all of that is recorded, as I say, in our install management system. So we've got a verifiable record, which can be audited, and that is includes information from the batch number of the product that's being used to the installer and the time that they took to do it. Bear with me. For some reason, it's always a little bit slow moving on to this slide. There are a number of schemes outside of Green Home Grant voucher scheme, which our measure is eligible for. And that's in part because we have a BBA certificate, the British Board of Agreement, which certifies that Cubot's processes, install, measure, and insulation all meets all the necessary building regulations to be used in a domestic setting in the UK. For those of you who are familiar with the energy company obligation, this is a levy that we all pay on our gas and electricity bills, which goes into a fund that energy companies need to spend on properties which are in fuel poverty, so low-income households. So if you can access that because of earnings, then you can potentially get a 25 to 75% of the cost covered. If you've managed to get a Green Home Grant voucher, you can get about 2/3 covered. And if you're part or eligible for one of the upcoming schemes, such as home upgrade grants or local authority delivery schemes, then potentially it can cover as much as 100%. But that is generally reserved for low-income households in fuel poverty. You can visit our website and look on Trustpilot. We have a number of reviews from both Google and Trustpilot about the impact of our solution. In fact, just yesterday, we published an incredible customer testimonial from our first ever private homeowner customer. So the measure's been in development, being deployed since 2014. We've had a focus on commercial and social housing properties. 2 years ago, we started looking at whether there was a market in a private homeowner market. And the very first property we surveyed in Scotland had a suspended concrete floor, in fact, had a suspended floor. However, it was too low for our generation of robot at the time to insulate. So we've persevered over the last couple of years to develop a robot that's small enough, and we finally got to install that last month. So it was a glowing testimonial on that, which is available on our website or on social media. So what's important is obviously the impact on you, the homeowner, the end user. As I say, you're typically looking about an average of £150 savings per year. We have an incredibly high referral rate, over 90%. And people notice the reduction in their energy bills and the improvement in comfort straight away because of the removal of drafts. And you may, if you haven't already looked, we have a YouTube channel. There's a number of testimonials and videos on there as well, which you might find useful. There's also footage of some of our more recent robots, which I'll try and share with you in a moment. Now, this may be of interest to some of you. Obviously, we know because we've patented the systems that we use and that's a number of developments, including the robot. They're patented in the UK and other countries. We have install partners in France. We've done work in the Netherlands, and we're currently looking at other territories like North America and Japan. We know there isn't really another method out there for insulating suspended timber floors. So what we're competing with is with the funding that's available, either from you as individuals or as, from local authorities, around energy efficiency measures in general. So we've had a look at the cost per SAP point improvement of installing our measure against installing the other measures. So basically your bang for your buck. And after loft insulation to a depth of 270 mil, which is the most cost-effective way to improve your energy efficiency, comes underfloor. Beyond that, things like internal and external wall, although they will deliver more energy efficiency, more energy savings, their high capital cost means that their cost per SAP point improvement is not as effective. And whilst we all like new double glazing and see the benefits of it, actually it takes an awful long time to pay back. So say underfloor insulation won't make annual energy savings quite as high as internal or external wall insulation, but it doesn't have that high capital cost. And we're currently seeing external wall insulation for properties in the region of about £15,000 to £20,000. It's a really significant outlay. Whereas say we're looking at just under £3,500 as an average cost for our underfloor. That means the payback period is much quicker. You're looking at 10 to 15 years realistically. And a lot of these calculations, and certainly on savings, were done based on early 2020 gas prices. So we know that the cost of heating homes has increased significantly in recent years. So hopefully that's all useful. I'm just going to switch between screens and bring up some video footage to share with you, and then I can happily answer any questions. Never quite goes as quickly as you'd like. Go ahead, Andrew, by all means, while I'm queuing this up.
Okay, I'd be interested, firstly, I'm probably outside your remit completely, but do you have any recommendations for solid floors?
Solid floors, yes, far trickier. There's two approaches. Well, yeah, there's two main approaches to solid floors. If you're going to use a kind of structural extruded foam, you're probably going to need at least 50 to 70 mil increase on top of your floor, which would mean, depending on your ceiling heights, it might mean that it's not suitable. You're going to be potentially required to move your door frames as well. So if you've got the ceiling height and you've got the will, it's incredibly intrusive, but you can apply insulation on top of the slab. If you don't have that much room, there are aerogel materials which are much slimmer, so sort of 10 to 25 mil, which you can lay almost like a thick underlay without having to lift your floor height so much. But you will always lose a bit of space, unfortunately.
Yeah. Sorry, what was that called? The last one?
Aerogel.
Aerogel. Okay.
Yeah. High performance, high cost insulative layer.
Is it? Yeah.
Yeah.
The other thing is, when it's when you're normally doing, do you make allowance for electric cables and plumbing and things like that, which tend to go under the floor, either parallel with the joists or very often slung underneath the joist? And of course, there is very often a necessity to get to that for the odd bit of maintenance or something like that. Central heating pipes start leaking or something like that.
Yeah. So there's very clear directives. We can insulate water pipes. They can be encased so that they're protected. We can't spray insulation foam on other services like gas or electricity, so they would be avoided. And the maneuverability of the robot and the flexibility of the turret and delivery system, and the fact that the foam expands on contact, means we're able to position the robot to spray beyond the obstruction and fill out the area behind it. I've queued up the video, which I'll share now, which will hopefully bring that to life for you. There's no sound. This is the Mark 7 operating in an underfloor environment in our test facility back in Wandsworth. Sorry. So this is the operator view. It's got a targeting system there, as you can see, just applying a thin layer which starts to expand to seal the floor. And the operator can use the robot and manually target, or it can use one of these preset patterns to ensure that you get kind of consistent coverage. What they're doing is positioning the robot, as you can see, between the rafters. The pink dot indicates where your turret will fire, and that green line is the automated pattern that it's spraying. So it's building that up in layers of about 50 mil at a time. I'll just jump forward a bit and the robot will turn around and you'll get a view of it from the other side. You can see the tether it's towing, which supplies both the power and the foam. It's quite thick, quite cumbersome. We can operate up to, I think it's 50 meters away from the van. So there's quite potentially a lot of it to pull and maneuver around. Obviously, this being a test facility, you've got to, we wouldn't usually have this good a footage from underneath the floor. The robot can video and record imagery from its own camera, which is kept as a record. You can see using all four wheels to turn on the spot. You've got the gun turret at the front there. The technology will assess the depth so that it can compensate in terms of the spread of the spray. And there you go, you can see it being sprayed. So it's a very thin mist, and then when it hits the cold substrate, it will then start to expand. And that's all about controlling the temperature from in the van along the pipe so that it hits the right temperature when it's being sprayed. But you can see from that how you could position it in almost any location in the floor and then spray beyond or around any potential surfaces. So hopefully that's useful.
Thank you very much,
No
Leigh.
problem.
Excellent talk and very interesting indeed. Let's open it up to the floor, as it were. Any questions from anybody?
Go ahead, Tony.
You're on mute, Tony.
Yeah. Yes, that was fascinating. It's certainly of interest. I just wondered, you know, there's bound to be a number of dwarf walls holding various floorboards in different locations. Would you anticipate having to take more than one entry point?
Yeah, it does. It's very specific to the property. We would usually expect that there'd probably need to be two. But some dwarf wall configurations are designed so that actually you can move between them. Others are often honeycomb and the robot can push through. So you would have a beam balancing on top of a dwarf wall that was honeycomb. So you could push through a few bricks, wouldn't compromise the structure in any way because you've got this bridging beam over the top, and therefore access other parts of the floor. In the worst case scenario, yeah, we might need multiple access points. It does depend, you know, it's very specific to the property. You
couldn't, or do you ever come in from the outside if there's sufficient clearance?
Not anymore. So we have done in the past. An earlier generation of robot was designed so that it could fit through a smaller gap, but as they've got more sophisticated and more robust and heavier, then it makes it impractical. It is possible because we can also insulate suspended concrete floors, so properties with block and beam, in which case we just need a specialist contractor to create an access hole in the floor, in the wall outside, and then brick it back up afterwards. So it can be done, but we don't recommend it because there's an extra significant cost to that.
Right, that's fine. You know, not our particular property has either got carpets down or you know, wood strip floors. Presumably you'd have to go into a room that's carpeted and pull the carpet back to reveal a suitable amount of the floorboards underneath to work with. But you know, obviously your survey would have to identify where you can get underneath the wood strip floors, because it's difficult to remove those, I would have thought.
Yeah, there are some floor coverings on top of the bare floorboards that are more difficult to deal with than others. So our teams are trained to lift carpet and relay that, and lift laminate where it's been correctly laid. So where there's a beading on the edge of a skirting board. Because if it's been wedged underneath a skirting board, then that's much more difficult. So we wouldn't lift that because of potentially damaging it, but that's not to say that the homeowner or the individual couldn't lift it themselves or get somebody else to lift that, or parquet flooring, or for instance tiling. But we would leave that as the decision and of the homeowner.
Yeah, fine, thanks very much. I'll have a look at your website.
Absolutely, thank you, Dave. I saw you.
Incidentally, sorry, the
That's
website
right.
address has just got co at the end, not com.
That's correct. Yeah, just
right.
Yeah.
Fine, thank you, Leigh.
No problem, Tony.
Do you have a question, Dave?
Yeah, thanks, Leigh. That was a really interesting presentation, actually. So I wasn't sure I was going to be interested to start with, but I think I am now. Just one question that just arose when you did that final video is, if you do need to get into the floor afterwards, what's the structure of it? Is it hard, soft? Can you cut through it, or
it's
how
hard.
would you get in there?
Whilst it looks quite fluffy, it's a very solid foam once it cures, which takes only about 60 seconds. So we can provide guidance of how to get in. So obviously our teams will create access points.
Yeah.
The recommendation is to use those access points to go back in, and we can give guidance on how you would cut, a contractor would cut that, so that it create basically a plug that can be taken out so that they can access the floor void space, and then that plug can go back in, so it doesn't massively compromise its performance.
Okay, yeah, thanks.
Righto, thank you. Any more questions from anybody? Yes, and Pitwell.
Hello. How do you measure that it's been fully sealed? Because obviously that's the crucial thing, isn't it? Not to have any little gaps where you can get the air and the mold starting.
Sure. So that's part of the kind of verification process. So because the foam expands, it naturally fills out all of the spaces in front of it. So that makes it much easier for us, because the foam will find its way into the gaps. The robot collects, as I say, video information and images, so that then it can be independently verified by one of our team. So yeah, so we'll never be able to completely eradicate all drafts, but we'll be able to make that significant improvement on the floor.
And how do you, or do you measure the before and after, to give you the... Yeah.
So basically, the information we collect at survey, the thickness of the floor covering, the size and spacing of the joists, all allows us to calculate the current U-value performance of the floor. And then post-install, with the application of the foam, we're then able to calculate the post-install performance. So typically, I say we get about 0.18 to 0.22 watts per meter square Kelvin, which is the measurement of U-value or thermal conductivity, and that's about a 75% improvement on most suspended timber floors.
Thank you. Thanks, Leigh.
Okay, thank you. Any more questions? I'm just going to put a quick advert up.
One question then.
Go ahead.
If you can still hear me, internet.
Yeah, far away, Dave. I'll just put that up for the end of the video.
This eco-free innovation uplift, right? Do most people qualify for that of some description, or should I bank on getting 20% at least, or
eco funding is typically means tested for households with an income of less than £30,000 is the usual criteria. If there are different conditions in terms of receipt of certain benefits, which would also apply. And there are certain schemes in different parts of the country. And interestingly, I was talking to Shropshire Council only yesterday about a local authority delivery scheme that they are funding and working with March's Energy Agency, who you may or may not be familiar with. But if certainly in Shropshire, if you were interested in finding out more, I would recommend contacting March's Energy Agency and having a discussion with them.
Do you know of March's Energy Agency? Yeah.
You're fading a bit, Dave.
But if I came to you and you doing a survey and such, you would advise on what's available, or would that be thing to go and find that?
So we don't do any of the means testing components to establish that. So it need to go through one of these local authority led schemes.
Okay, fine.
Sorry, Dave. Bye.
Dave will come and go. He's got terrible connection up there. Right, just to conclude, we obviously have these Ask the Experts talks during the course of the year. We're planning a few sessions for next year, but they're not fully been agreed and sorted out yet, but we'll keep you in touch. Can I thank everybody for coming? Much appreciated, and especially Leigh for a very informative and interesting talk. Absolutely fascinating as far as I was concerned. But can we thank Leigh, please? And yeah, thank you.
Very much. Thank you for your time.
And
Many thanks.
I imagine a few of us will be in touch soon.
Fabulous. Well, yes, do let me know if I can help.
Will do.
Cheers.
Thank you, everybody, for coming.
Bye now.
Cheerio then.